Welcome again. Welcome to the IBAC webinar number 4. I am Vishal here. Today we have Gurneet Singh, who will be delivering a webinar on a very important topic, that is integrated design approach, a key to optimized design. Gurneet has a background of architecture and engineering. He has over 12 years of experience in projects dealing with sustainable development, building energy efficiency, and green buildings. Gurneet leads EDS team with over 50 professionals working on green building projects globally. He has worked on some of the landmark green buildings and many large and small developers to integrate green building principles from an early design stage. Gurneet amalgamates the rare knowledge and understanding of sustainable building environment from design and on-site engineering perspectives. He is also an expert in various modeling and simulation tools such as Visual DOE, EnergyPlus, eQuest, and Radiance. So Gurneet will be giving a webinar for about 45 minutes on integrated design approach, a key to optimized designs. After this, if anybody has questions, you can use the menu in the questions box and ask the questions, and Gurneet will answer those questions. We'll be transferring the control to Gurneet now. Thank you. Welcome, Gurneet. You are the presenter now.
Right. Thank you, Dr. Vishal. I hope you are able to see the presentation. A very good evening to all of you. I am Gurneet from Environmental Design Solutions. We work in the area of whole building analysis, optimization, green buildings, research and policies. First of all, thanks to IBAC and its team for giving me the opportunity to present and share my experiences. As all of you are aware, today's topic for webinar is integrated design approach. So, in today's webinar, I will be covering why optimized design and why a need for integrated design approach, integrated design process versus the traditional linear design process, the whole process of integrated design, key elements of integrated design, how integrated design process results in high performance eco-friendly buildings, and finally various tools that help in integrated design. So the very first question that comes to our mind is, what is the need for optimized design? So let us quickly assess the same. Buildings in India consume about 29% of country's total electricity, and they have a significant impact on the environment and resources, indicating that there is a need to develop optimized design in India. So if you see the pie chart, buildings consume 29% of the electricity in India. Second to industries. There is a projection that around 1900 million square meter will be added till 2030 to the present built-up area of 659 million square meter. That means if we take the current, there is approximately 66% is yet to be built. So if the current is 659 million, there is 1900 million square meter that will be added. So there is a huge potential for savings in building. As we all know, the modern building ecosystem, like any other ecosystem, has input that goes into the building and an output given by the building. So building as an ecosystem consumes certain inputs and then produce certain outputs. So the inputs are like building uses material as input and give output as used material. Similarly, energy goes in and waste heat, carbon dioxide is given out. Fresh potable water act as an input and the output is a grey or black water or sewage. Consumer good to waste, recyclable materials, solar radiation to warm air, wind to polluted air, and rainwater to stormwater. So these are all inputs that are generally taken by the building, and on the left side is the output from the building. So the impact of this ecosystem is huge. So just to give you an idea, building consume 40% of world's energy, 50% of ozone depleting CFCs, 30% raw material buildings use, 40% of the landfill waste is contributed by building, 25% of the timber harvested is used in the building, and 35% of the CO2 emission is because of building, and 16% of fresh water is consumed by the buildings. So till now this slide we have got an idea that why there is a need to optimize the design. Now let's discuss why integrated design approach is required and why this new term. Why it was not required a couple of decades ago, and why in today's world environmental design approach or conventional design approach does not fit. So let us first look and understand how buildings and building design have changed over past few decades. So let us evaluate the scenario that was there in 1980. So approximately 3 decades ago, what was the scenario? In 1980, the population was less. Resources such as water, energy, material, I would not say abundant, but were sufficient. There was sufficient land available, that is huge site areas were there, and the demand for infrastructure was less. So in 1980 population was less, there was sufficient amount of resources available, there was land available, and the demand for new infrastructure was less. As a result of the above factor, the buildings and the building design in 1980 was very simple. Most of the buildings were low-rise, they were less complicated, and building services were also limited to electrical, plumbing, structure, and HVAC. HVAC also in very few buildings. So when we say buildings were less complicated, it refers to its services. The services in 1980s were very simple with only few elements as the advanced technology was still in development. So in electrical, majorly there were lighting and switches. So these were the two major components in the electrical in 1980s. Plumbing was about sizing and placing floor trap, gully trap, grease trap, and manhole. So that was all that was there for plumbing. Structure was frame structure, that is column and beam. And HVAC was about installing fans, coolers, and very few buildings used to have central plant. I might be missing, however, the message I want to give here is that the services in 1980s were less complicated as compared to 2010. So the lighting, plumbing, structure, these were were less complicated. So an architect was able to implement all of these and was able to optimize the design because architects were able to understand all these simple aspects of these services And when he used to design his building, he used to take care of all the simple factors and try to optimize the design. Now let's try to see in 2010. As seen, the services were not that complex. So now let's evaluate the present scenario and see what has changed. Now, in scenario today is totally the reverse of what it was few decades ago. The population is growing fast, at a fast speed. Resources such as water, energy, materials are available. There is a shortage of land, and due to population increase, the demand for new infrastructure has also increased. As a result of the above factor, there is a huge pressure on the architect to meet the demand. As a result, the present building and the building designs are complicated. Buildings are going high-rise, and more services are being added such as facade, transport, BMS, networking, and etc. Besides the new services, the present services due to technology advancement have become very complex. The electrical sensors control efficient lighting such as LEDs, TFLs are being added. In plumbing, new technologies like rainwater harvesting system, sewage treatment plant, dual plumbing, efficient irrigation system, drip or sprinklers, recycling waste water, etc. are being introduced. New type of systems are being added to the structural domain also, such as PT slab, flat slab systems. There is also a major shift we have seen in HVAC from a few buildings being air conditioned to almost all buildings. A whole new range of equipments and technologies have arrived in HVAC, and each has a different requirement in terms of space and design parameters. Some of the HVAC systems added are VRV systems, earth air tunnels, geothermal cooling, desiccant systems, water cooled systems, radiant systems, and chilled beam systems. So with the new technologies coming up in each area, additional services being incorporated, it is nearly impossible for the architect to master or keep themselves up to date on the technology and requirements for each of these services. Because of the increase in services and stakeholders, the need for integrated design approach is felt. So now let's try to understand how the traditional or conventional design process works and what are the pros and cons for the same. Conventional design process starts with the first stakeholder, that is the client, the developer. The client and developer has got 2 or 3 sites on which he can make his building. He engages a property firm to do a feasibility check on which site is more appropriate. The project management firm, based on certain demographic and transportation access factor, provides its recommendations. The client, based on the recommendation, decides on the site and hires an architect for developing the design. The architect develops 2 or 3 design options and presents it to the client. The architect and the client agree on the design concept consisting of general massing, schema, orientation, fenestration, and general exterior appearance. in addition to the basic material. The consultants are now asked to implement the design and to suggest appropriate inputs in the design. Each consultant works independently and develops the DBR, detailed design. The architect then incorporates the requirement for each consultant in the present design. The traditional process is a very linear process. In this whole process, at each stage, there is some amount of restrictions, limitations, or boundary conditions for the next actor. So the previous actor put some amount of boundary conditions for the next actor, within which the next actor has to work. Thus, the next actor is not able to optimize the design, as he has to work within those boundary conditions being set by the previous actor, having less knowledge of the domain. Just for example, the site selected may not be appropriate site in terms of orientation. However, now the architect has to design, and whatever he will do, he has limitations in terms of reaching the optimized design. So the conventional system of working is more of a linear process where at each level some level of restriction is added for the next level of actor. All these features are results of the design processes which initially appear quick and simple, but which then results in high operating cost and the creation of an interior environment that is substandard. Let me take you through real life example to justify the above statement. In one of the projects, the client selected the site based on certain factors and then hired an architect. The only way the architect could orient the building was an east-west facing building, keeping in mind the site orientation, access, and view of the building from the main vehicular road. The architect suggested three options with various windows, window to wall ratio configuration. The client selected the option with full glass facade as it is modern and aesthetically appealing. The design was passed on to the HVAC consultant for sizing of its equipment. Then the facade consultant was hired. He suggested shading to control the glare. The additional cost of shading, HVAC costs increased due to bad orientation. In another example, the architect designed an institution building keeping in PRV system. The design was approved by the board. The construction was started. When HVAC consultant came on board, he suggested a central plant system to enjoy the benefit of diversity and thus lower capital costs. However, since the architect designed its planning keeping in mind VRV, there was no space left for AHUs and other mechanical rooms. As a result, the construction was stopped for a couple of months. A lot of reworking on the drawings and space planning suffered in order to incorporate the AHU space. This all resulted in cost, time, and we all agree time also translates to cost. This slide shows the typical organization chart for conventional design process in which the client's primary contact is the architect who coordinates with the other team members such as structural engineer, mechanical engineer, electrical, landscape, facade engineer, and transportation engineer in hierarchical structure. Now let us now try to understand how the integrated design process is different. As against the traditional linear process, in the integrated design approach, all the stakeholders or actors are on board from the very first day, and each is able to provide his or her input at each stage of the project, starting from pre-design stage to post-occupancy. It is procedure considering and optimizing the buildings as an entire system, including its technical, equipment, and surrounding, and for the whole life span. This can be achieved when all actors of the project cooperate across all disciplines and agree on far-reaching decisions jointly from the beginning. So there is a project life cycle, and throughout the project life cycle, all the actors interact and give their inputs. So in the starting, maybe the transport engineer, the amount of input is low, but during the final execution phase, the amount of input may be high. So now to the next slide. The following figure shows the organizational chart for integrated design process in which the core team is expanded and is more closely integrated. So all the stakeholders try to talk to each other or work in an integrated fashion where they communicate with each other and try to optimize the design as a team. So not any hierarchical system where they work with architects and try to give their input, but they work as a team. So what are the various phases of integrated design? So the first phase is to set the benchmarking, to set the broad range of parameters. So in the initial stage, you set benchmark and sustainability goals, then develop preliminary strategies to achieve these targets. So you do evaluate the cost benefit and the environmental impact. It brings also engineering skills, perspectives to bear at the concept design stage. Then you, based on the project iterations, you set the project objectives. Then each one work with each consultant to meet the objective. Various design options are evaluated. Then during the construction, the procurement is also monitored, and finally end up with the post-construction and occupancy evaluation. At these stages in integrated design approach, there is a lot of iterations done where you need to evaluate and simulate and see which of the design option is good. So this is at this stage a lot of to and fro and analysis is done, and also at the final stage that once we have set the project objectives, you try to evaluate various design options. So this chart basically shows that if you follow the integrated design approach at the very start of the thing, the degree of effort in optimizing the design is low and the potential benefit is more. But as you move in the construction timeline, the potential benefit reduces and the degree of effort, both in terms of man days and in terms of cost, increases. Now, in order to achieve sustainability, in order to achieve the integrated design, there are sustainability tools available for integrated design. So I will quickly take you through various sustainability tools and how they can be used to optimize the design and be a part of the integrated design approach. The whole building design basically it provides, always you have to take building not as each component not as a one, but it works on a whole building design, because once you try to optimize the one aspect like the envelope, then it has impact on the cooling load. So we have to always make sure that it is approached in a whole building approach. So there are quantitative analysis generally you do. So there are tools available to do various kind of quantitative analysis for envelope specification like wall, roof, window, for energy in terms of lighting specification, central plant specification, water. There are calculations that can be performed for sizing the STP and the rainwater harvesting. What is building performance simulation? Basically, as we have said, we have to approach the problem as a whole building problem. So there are complex and rigorous calculations related to energy processes within a building using computer models. There are advanced software packages available that are capable of calculating building energy performance hour by hour for an entire year. Why we need a building performance simulation? These are basically a powerful tool to analyze how form, size, orientation, and the type of building system affects the overall energy performance. These building performance simulation tools can be used for optimizing energy, lighting, daylighting, HVAC design, IAQ, and other aspects of the building. So there are various tools available in the market, from ranging from Energy Plus to Trace. The next slide shows you in brief the process. The process is that you model the building information into the simulation tool. You give inputs in terms of weather data, position of sub, and you take the software tool gives output in terms of electrical consumption. Some of the examples of building simulation applications. First, let's start step by step, and these also forms the steps for integrated design approach. So the first and the foremost task is to do the microclimatic analysis, because that will form the basis for each consultant, whether it's the HVAC, whether it's the lighting, or the architect, or the structure. These forms the guideline for doing the analysis. So there are microclimatic analysis, there are solar analysis, wind analysis, and weather data analysis. So there are tools available which helps in analyzing the solar movement for the place. So you can actually see how the sun is moving during different time of the year, in different months. I think there are movies, but I think it's not displaying. So then there is also like the wind analysis. So first you have done the solar analysis, then the wind analysis. So these are like windrows diagram that tells you how the prevailing wind direction, their speed. So you can design your building for natural ventilation. There is weather data available for 2100 locations, and these weather data has got 24 cross 365 days, the dry bulb, the wet bulb, direct radiation, diffuse radiation, cloud cover, and the wind speed. So you can analyze this data and find out the temperatures, the cloud cover, radiations, and humidity. Once you have done the microclimatic analysis, the next step in the integrated design approach is to come to the site level analysis. So climate analysis helps us in understanding the parameters for the location. Site level analysis helps us in understanding the site related issues, the surrounding issues, what kind of shading, mutual shading is done by the surrounding buildings, whether they are blocking the daylight or they are blocking the wind movement. So there are tools available that help you in analyzing the shadow and other aspects. Basically, these slide shows how the shadows will move to the side, which are the overshadowed areas, which are the undershadowed, overexposed areas which require shading. Yes. Then there are tools available that can help you do wind analysis for the site level so that you can identify which are high pressure zones or low pressure zones. If any building is blocking the movement of the wind, like in this case, there was this multi-level car parking, so it was blocking the wind movement. So we asked them to open up the lower floors so that at the ground floor, at the pedestrian level, the wind can actually pass through the multi-level car parking. Then once you are through with the site level, the next step is building level. So there you can do orientation, mutual shading, wind analysis at the building level, and the daylight analysis. Just to give you an example, in this slide, if I design my building in isolation, so this is my building. If I have to give inputs to the architect, I will say that okay, this facade is getting direct sun hitting on this facade. You should go with a high performance glass. You should provide minimum window on this facade. But when I take the surrounding buildings into account and try to do the shadow analysis in that aspect, then the whole scenario changes. So when the surrounding buildings are modeled, the sun is modeled. So if you can now see in the slide, actually this is protected from the sun by the surrounding building. So now the recommendation changes. Like now we should go with more windows on this facade, and we can go with a less performing glass, low performing glass. Similarly, the next example it is on the orientation. So this is a resort unit which has got 3 bedrooms. So we try to rotate it in different direction and try to find out what is the cooling load for each orientation. So finally so on the right hand side is the cooling load for different orientation. So finally we were able to find out that okay, for the lowest cooling load is in the southwest direction for this kind of building, which was coming down to 7.77 tons compared to the for different orientation. Similarly, we can do mutual shading, how the surrounding building is making impact on this building, what kind of shading we require, whether horizontal shading is work, and to what depth the shading is required in order to block the sun. Whether you require 1 shade, 2 shade, 3 shade. So then now you can basically with this simulation tool can quantify, and this basically helps the design team of the integrated design process to actually evaluate and optimize the design. So the same input like on the architecture will also go as an input to the HVAC engineer for his heat load calculation. So he can quickly do the calculation and tell that okay, if you add shading, yes, there is a reduction in the tonnage. So the architect can evaluate various options based on that. So when they work as an integrated team, they can actually optimize the design. So now this slide, the next slide shows about the daylight analysis. So this is the interior and this is the rendering from Radiance tool, which actually quantifies the lux level achieved in the space. The next slide shows about the comparison between 3 types of window configuration. So there is single window on the top, then there are 2 windows, and the last option is 3 windows. Thermally, all the 3 options are same as The total area of the window is same. We have only distributed, but if you see in terms of daylighting on the right side, these are the plan views. So you can see there is, for the top portion, there is a glare portion coming out. There is a lot of light coming directly in the center of the room, whereas in the bottom portion, the light is very much uniformly distributed. The next slide talks about the shading, where you are comparing two design options and their simulation results. So this slide, the final slide, actually shows about, there are two graphs showing the daylighting levels for towards the south facade and towards the north facade. So there were these two options. One was without overhang, one was with overhang. And what we were able to figure out from this analysis was that on the south facade, adding a overhang makes sense. This was a building in North India. Adding a overhang makes sense because you get direct sun hitting the overhang and then get reflected deep into the office space. Whereas on the north side, adding an overhang actually blocks the diffuse light. So it was not useful. So this kind of input generally the architect can use in trying to optimize the design. Then the wind analysis. That we earlier executed for the site level, that can be done for the building level in order to understand the potential for natural ventilation. I think there is a lag between the slides. Yeah. So different design options for the building can be evaluated. Then the next part is on the building energy analysis and simulation, where you try to optimize, you try to model the building and in the energy simulation tools, and the output is given in terms of the energy consumption for lighting, for equipment, for HVAC, and the total. So from the energy simulation tool and during the integrated design process, one can do the energy efficiency cost benefit analysis. So this is a chart showing various ECMs, which are called energy conservation measures like shading, high performance roof, wall, glazing, and the reduced lighting power density, and different kinds of HVAC system, underfloor, air distribution system at various set points. The output is given in terms of annual energy consumption. You put a cost to that and do a quick cost benefit analysis so that you hotel building. So this hotel building is basically east-west oriented. So half of the rooms are on the east side and the other half are on the west side. This shows that thing, but you just watch. Sorry, this thing, the cooling load, the lowermost blue line. So you can see that here the east-facing rooms are having their peak cooling load at around 10 a.m., whereas the west-facing room have a cooling load at around 4 p.m. So there is a diversity and there is something you can offset it. So actually you need not to double for your central plant sizing. You can take around 75% of this load and do that. So it's a non-coincident load that helps in. Then it also, the simulation tool helps you in doing the load analysis in various months. What is the cooling load, hourly cooling load. So the what I want to just end by saying is that a collaborative integrated design approach with project life cycle cost makes for buildings that are healthy for users, profitable for the owners, and sustainable for the environment. That is what we call it as an integrated design approach. And with this, I would like to end. Thank you.
Thank you, Gurneet. Thanks a lot for interesting presentation. Of course, you just scratched the surface. There is a lot more to learn here. Anyway, it's a start, and we hope to get more webinars getting into details of the integrated design. If anybody has any questions, you can post it in the questions tab, and Gurneet will try to answer those questions. Gurneet, I am getting some questions. I will forward those questions to you. Just a minute. So you will see in the questions, just a moment.
Sure.
Gurneet, you got the question?
No.
You will see it in the
Chat box.
GoToWebinar. No, not chat box. Questions. If you go to view
Okay. Questions.
questions.
Yes. How to increase the screen? Okay. So there is a question from Umid Khanna. Do project fees allow for payment to be made to consultant during pre-design stage? Yes, one thing we have to understand and the client has to understand that if they consider the fees for the consultant in the pre-design phase for the consultant, maybe for conducting a design charrette or something, they will save around 10 times of that fees in the optimized design and doing less of rework, and in terms of reduced tonnage, just to give you an example, reduced tonnage or envelope optimization. So that is something that the client has to understand, or we need to educate to the client the benefits of involving the consultant during the pre-design stage. The next question is from Sandeep Dahiya. Integrated design approach must have M&V to ensure that the design aspects really contributed as simulated. Yes, so as I explained in my process, there are various stages. So the last stage is the post-occupancy evaluation, and I totally agree. And in many of the projects, they try to do the M&V post-occupancy in order to calibrate their model and see that they are meeting the design aspects. There is another query from Amit Khanna. Normally consultants are an expensive asset, so making sure they are on board during the pre-design is a call that needs to be made by the client. Yes, I totally agree. They are expensive asset only for the client, but if you see in terms of the overall project cost, I feel that the consultants are not that expensive, especially in India. Then there is a question or remark from Sandeep Dahiya that simulation assumes perfect control, which is not the case in reality. Yes, but see, when we design our building, so it's not about simulation. Even when an architect designs the building or takes the design brief from the client, or the client gives the design brief, they are also done on assumptions. So many a times the client says that, okay, I want to design the building for 1,000 people, but if later on there is a call center or BPO, then it suddenly becomes 1,500. So what I'm trying to say that one of the component for which we design the building is the occupant, and occupant behavior is very difficult to simulate. Simulation helps you in the integrated design approach in order to optimize the design or to compare various design options. So when you're comparing various design options, you keep certain parameter constant and try to see that, okay, option A versus option B, if I keep the rest of the things as constant, which one is the better option. So, but yes, after the occupancy, the simulation model has to be recalibrated based on the actual input, and then you try to optimize the operation during that phase. Sandeep Dahiya has again said that integrated design approach should include operational and maintenance team also, so that operational competence is taken into account and systems are not unnecessarily complicated. Yes, I also totally agree with that aspect. And also the operational maintenance team should be taken into integrated design approach, because many a times operational maintenance team is not aware of the features of the building. So they are given a building, but they are not aware how to operate or what are the features. Like, just to give you an example, there were like daylight sensors available, but the operational maintenance team was not aware of that. So there is what we observed, there is a disconnect between the project team and the operation team. And also during the decision phase, the project team take a decision mostly on the cost basis that, okay, this is an expensive thing, let's forget it. But they never take into account the operation savings. So they have a understanding that, you know, we have been given this much budget, we have to try to complete the building in this budget. So yes, you're right. The operation team also should be taken into the integrated design approach. Shanuli Gupta has said, usually architect who is himself interested in integrated approach does it on his own free will. They do not hire any consultants. So where do people like us fit in? See, as I've said that, you know, now the buildings are very complicated. You know, in 1980, there was no consultant. Like I never heard that an architect to hire a facade consultant or a transport consultant. So now, but yes, the architects are now hiring facade consultant, not of their own fees. Uh, but yes, now people are hiring it, and I feel architect can hire these consultants if they are provided a service at a very low cost. Maybe something like doing a 2 weeks of job, doing a quick daylight simulation model, and that is. So there is a huge scope, and with the ECBC thing coming up mandatory, and the laws, the MOEF requirement, and other things becoming stringent, I feel there is a huge way you can contribute towards integrated design approach. Now there is a question from Balaji NC. What will be the importance or role of consortium in integrated design to execute efficiently and effectively? As I have explained in my presentation, that when you have a consortium in terms of different consultants working together, so the different aspects of the design are not only evaluated by one person. So because each of the design aspect has an implication on the other part. Like if the architect is putting 100% glass, that will have an implication on the HVAC cooling load. So when they work as a team, so if they as a team they decide, just for example, that okay, our building to have a load of 400 square foot per ton. So if they have put that target and architect says that okay, I want 100% glass, then the HVAC consultant can quickly tell him that with 100% glass it will be impossible to achieve 400 square foot per ton. So let's try to optimize the design, and the cost consultant can say that okay, you are going with glass. If you want this, you need double glass. That will add to the cost. So now let's try to have a reasonable window wall ratio that will meet the daylighting thing and also aesthetically will look good. So there is a important role of consortium in the integrated design. Nitin Narang asked the question that do you think LEED and GRIHA project automatically forces the integrated design and is a way to go for complex building? The latest version of LEED and the upcoming version of GRIHA addresses this issue of integrated design, where you have to show the whole design process, the integrated design process, and you have to document that you started from a shoebox model, you have done 3-4 orientations, and based on certain parameters you have finalized this orientation, then you have done. So the LEED version 4 and the upcoming version of GRIHA, there are sections that talks about the integrated design approach, and I feel that the latest version buildings that are going, they will automatically fall, or will automatically, this version will force the integrated design in the complex building.
Gurneet, I think Mamta Verma has a question. Mamta, I have unmuted you. You can ask your question now. Can Mamta Verma hear me? Hello? Okay, looks like okay, so there was a hand raise. Anyway, so if anybody else has any questions, you can paste it in the questions menu. Okay, I don't think we have any further questions. So I'd like to thank Gurneet and all the participants for participating in this webinar and asking questions. Uh, we from IBEC invite everybody to send us some suggestions on what topics you would like to have webinars, and who are the speakers you would like to see in our future webinars. So your suggestions and recommendations are welcome. And Gurneet, we hope to see some more webinars from you on energy simulation and maybe some case studies and some more intricacies of the design. And we all thank you a lot for this webinar. This webinar is recorded and it will be available on the IBAC for future reference. So thank you all. Thank you, Gurneet. Bye-bye.
Thank you for inviting me. Yeah, bye.